Looking at section 10.4, talking about prediction intervals and variation. Okay, so a prediction interval is an interval estimate of a predicted value of y. Interval estimates of parameters are confidence intervals, but interval estimates of variables are called prediction intervals. So basically we're going to step away from where I was talking about confidence intervals just to kind of relate it into that 0.05, and now we're going to call them prediction intervals. Okay, so a confidence interval is the range of values used to estimate a population parameter. But a prediction interval is a range of values that is used to estimate a variable, such as a predicted value of y in a regression equation. Okay, so once again, here we're going to be talking about our requirements. We'll be talking about our y hat minus e is less than y hat plus e, where e is this nice, very complicated equation as we start going through. So do realize that within here we're talking about a standard of error. Okay, so we got a couple other formulas within here that are a little bit more simplified within. So as we're predicting in here, we're going to be saying, okay, well, this is our predicted one, but we're going to allow some error in here. So we're going to give ourselves a range for these prediction values within here. So some explained and unexplained variation. So there is sufficient evidence to support a claim of linear regression between x and y. The equation of the regression line is y hat equals 3. The mean of the y values would be here y bar equals 9. One of the pairs sample data, x equals 5, then y equals 19, so the 0.513. So they start saying that, okay, well, what's going to be better, what's not going to be better. Given within here, this is what we start comparing to. So we start comparing to a graph saying that this is what's predicted, but we could have somewhere in between. So we talk about unexplained deviation, we talk about explained deviation, and then we talk about total deviation in between. Once again, depending upon what's going on, if we're following our y hat line, we're going up here. If we're following our y bar, this would be the mean of the y values here. We start referencing some different values here depending upon what the situation's going on. So we talk about total deviation is y minus y bar. Explained deviation is our y bar, our y hat minus y bar, and then unexplained deviation is y minus y hat. So these are some things that when we start talking about deviation from our variable and how are we working with it, these are some things that we really want to kind of note down, just because it does help us determine whether we can explain this, we can't explain it, what's totally going on here within our whole problem. Continuing on here, just a little more explaining right here. They talk about the total variation as the sum of the squares, explained variation, unexplained variation. So rather than deviation, they relate them to variation. So the coefficient of determination. So the value of r squared is a proportion of the variation in y that is explained by the linear relationship between x and y. Okay, so once again, r squared equals our explained variation divided by our total variation. And this is that proportion that is explained in our regression line. So this is just something that, how do they find that r squared value? Now do realize there's quite a bit of piece of information in here where we've been given information and we're going to be using our calculator to find a lot of our values. So don't think that we have to have every single formula memorized and what's going on, but we do want to know what are these values meaning behind this, because do realize part of this class is explaining everything that is going on.